We're moving on to a new type of function. All we've been doing all year so far is with functions are straight lines, linear functions. Now we're going to get into exponential functions. So I'm going to do a little quick review on exponents. What is 4 squared? Hopefully everybody knows that that is 16 and not 8. When you have an exponent, that tells you how many times to multiply the big number called the base number together. So that's your base number, and this is your exponent, and the exponent is the boss, and it tells you how many times to multiply the base number together. It's not 4 times 2, it's 4 times 4. So if it was 4 to the third, the exponent is telling you to multiply that 4 3 times in a row, which is 64. Okay, I think you know that. What may be new is when you have a negative exponent, which we will have in this section. So a negative exponent, I usually present this to the class, and I get a lot of negative 16 as a potential answer, which is logical. That's a good guess, but it's unfortunately not correct. A negative exponent does not make your answer negative. Remember, the exponent's the boss. It's telling you what to do with this big base number here, but it's not telling you to turn it negative. What it's doing is it's saying to flip it, to do the reciprocal. So 1 over 4 squared is what 4 to the negative 2 is equal to. And then you just do 4 squared like you normally would, which is 16, but now the 16 is in the denominator instead of the numerator. So 4 squared is a regular old 16. 4 to the negative 2 is 1 over 16. It's the reciprocal of 4 squared. Positives and negatives, they're reciprocals of each other. All right, that's your basic review. Now let's get into an actual function. Y equals something. And here's where it starts to look a little different. We've always had y equals something times x. That was our linear function. And we still kind of have that, but now x is an exponent. That's why these are called exponential functions. So x is up in the exponent position, not the base number position like it always has been all year. All year it's been down here. It's been y equals 2x. And x has been a regular old number. So if x is 3, then your answer is 6. You've just been plugging in a regular number and 2 times that number. Now, x is not going to be a base number. It's not going to be a regular old number. It's going to be an exponent. And we're going to substitute in 3 numbers for x, one at a time, to make our chart. We've done this all year, making charts by substituting in numbers one at a time. But now we're substituting those in for an exponent. So our very first one is a 0. So y is going to equal 2 times, or not, 2 to the 0 power, because x is an exponent, and right now we're using 0 for x. So 0 as our exponent. And what does that mean, 0 for an exponent? There's a way I could try and explain this if you already knew the division rule for exponents, but you don't know that yet. So I'm just going to tell you the answer right now, and you're just going to have to trust me that 2 to the 0 power equals 1. 3 to the 0 power equals 1. Negative 4 to the 0 power equals 1. 5,436 to the 0 power equals 1. All right, I just made up a big number there because I'm making the point that anything to the 0 power equals 1. Doesn't matter if it's a negative number, doesn't matter if it's a huge number, a small number, it could be a fraction, 1/2 to the 0 power, that equals 1. Anything to the 0 power equals 1. So now that we have that out of the way, it'll be a little bit easier to figure out or fill out this table. Anything to the 0 power equals 1. Anything to the first power just equals itself. So 2 to the first power is just 2. If If it was 3 to the first power, it would equal 3. If it was negative 4 to the first power, it would equal negative 4. If it was 5,436 to the first power, it would equal 5,436. So it's a little bit different when the 0. Remember on the 0 power I said it didn't matter what it was, it equaled 1. It could be negative, still equals 1. Now it just equals itself. So if it's negative, it stays negative. If it's any big number, small number, it just stays whatever as it started at. So we started with a 2, we're going to keep a 2. And then 2 squared is 4. Let's do one more, 3. 2 to the third power is not 6, it's 2 times 2 times 2, which is 8. 2 times 2 is 4, 4 times 2 is 8. All right. Over here, 1/2 to the 0, 1, 2, and 3. Anything to the 0 power is 1. Doesn't matter if it's a fraction, a negative number, a huge number. Anything to the first power is itself. So 0 and 1 are kind of gimmies. Now we're going to get into squared. You're going to square 1/2. 1/2 squared is equal to 1/2 times 1/2. Remember, the exponent tells you what to do at the base. The exponent is 2. It's saying multiply that base twice in a row. Just happens to be a fraction, but that's okay. You know how to multiply fractions. 1/2 times 1/2 is 1/4. 3 times in a row, that's one more 1/2. 1/4 times 1/2 is 1/8. So you notice the pattern here. It's pretty much the exact same thing as this, but it's the reciprocals because we started off with the reciprocal. Now, if you want to graph these, which you probably don't, but you're going to have to, it's the same concept as before. These entries in your chart are points on the graph. 0, 1 is right here. 1, 2 is right there. 2, 4 is up here. 3, 8, now we're talking way up here. It's no longer a straight line. It curves up. These numbers the y's start getting a lot bigger real fast. If we went to 4, that would be 16. If we went to 5, that would be 32. You can see the y values are getting bigger a lot faster than the x values are, so this line is going to be going up real fast. Over here, 0 is 1. 1 is 1/2. 2 is 1/4. 3 is 1/8. So this line graph would look like that. It's never going to quite touch the x-axis because y is never going to be 0. It's just going to be a smaller and smaller and smaller fraction. It's never going to quite hit 0. But what these two graphs have in common is the point 0, 1, and that happens almost all the time with exponential functions because when you plug a 0 in for your exponent, you're going to get a 1. It doesn't matter what you're starting with here. If you're starting with a whole number, if you're starting with a negative number, if you're starting with a fraction, when you plug in a 0, anything to the 0 power is 1. The only time your graph is not going to go through 0, 1 is if this exponent term is being added or multiplied with something else. So what do I mean? Let's say we have the function y equals 3 times 2 to the x. Now if you plug in a 0 for x, you get y is equal to 3 times 2 to the 0, which is y is equal to 3 times 1, which is y is equal to 3. So when you plug in a 0 into this function, you get 3 for y. So that's when the graph will not pass through 0, 1, is when the term with the x in it is not the only term in the function. If it's not the only term, if it's being multiplied with another number or added with another number or subtracted, then you're not going to get 1 because you'll get 1 for this term and then this other one's going to change it, whether you're multiplying it or adding it. And you will have problems in the do section like that. They'll just give you a function and ask you, does this pass through the point 0, 1? And this is what they're saying. If it's just some number to the x power, then yes, it passes through 1. But if it's some number to the x power with another number being added or multiplied to it, then no, it does not. So that's a basic introduction to exponential functions. I'll get into more detail with this tomorrow.